How is everybody? Good. So this is my first talk after a year and a half. I've done a lot of webinars, a lot of roundtables, gotten used to being able to do this online. Our first sales kickoff after this past year and a half, I took this laptop, which I got in the middle of the summer of 2020, and realized I'd never taken it off my desk before. So making sure I have all of the components. So I'm going to be a little bit rusty, but you should be here for Rise of the Next Gen Software Supply Chain Attacks. I'm going to keep it kind of light, probably won't go the 45 minutes. I do want to make it interactive if you've got questions. I clearly spent more time on the slides and the pumpkin, all things open logo. The content's pretty straightforward, but just wanted to bring a little levity, which is probably needed after a long day. So again, let me know if you've got any questions. I'll repeat the question and then we'll go forward. So I'm Maury Cupitt. I am the Director of Pre-Sales, Sales Engineering of Sonatype. I've got a pretty varied background. I think like a lot of folks in this room, everything from ham radio to private pilot to my degree is actually a Bachelor of Fine Arts in Sound Design, Theatrical Sound Design from the North Carolina School of the Arts. It applies much more than I thought it would in sales and technology. Been doing this since building websites and internet-based applications and mobile applications since 1995. Yes, my HTML editor was a Word macro, right? So again, we got to work for some great companies, learned a lot on the way, and just happy to be here. So all things open. One of the other things I like to do is I love Halloween. Show of hands, everybody, maybe. Yep. Love decorating my house. I'm blessed with a house that calls for decoration. It's a 2-story Charleston style with the 2 porches. And if you decorate it well enough, it looks like a haunted little mansion. So my tribute to all things open in terms of the projects is the latest this year is these little blinking lights in the bushes, right? So I don't know about you, every year on Amazon, the LED brightness and quality gets better and better and better. So hook those up to an Arduino and a little relay. And this is the rat's nest on my side porch that's feeding, I think, 8 sets of the little lights that are blinking. But again, just having this kind of technology available to us, right, as a developer, as a tinkerer, is a lot of fun. So I put them in a little piece of Kydex. Kydex is moldable plastic, and then you put the little eyes. They actually have a little slot there, so you can see the little edges. The black doesn't show up at night; shows up a little bit during the day. But yeah, if you're like me and you're really interested in these kinds of projects, my favorite new kind of open gadget, probably not open, are these wire connectors that you just pop up and close. So they are fantastic. That's $17.99 for, I don't know how many that is. That's a whole box full. It's, 2, 3, 4. I use them for lots of projects. So that's my contribution to the open community today. Any questions on Halloween? Okay. All right. So I start all of my talks to kind of remind us why we're here, why we're building software, if that's what you're doing, if you're a developer. And during the COVID times, right, there's a quote from Deming: to create a constancy of purpose and dedication to their improvement of competitive position, to keep the company alive, and to provide jobs for their employees. The summer and fall of 2020 couldn't be more what we needed to do, right? And just so you know, constancy is the quality of being faithful and dependable. Right? So why we're building software is so we can be competitive, we can have jobs, and we can keep the company alive. Like everything we do in terms of DevOps and DevSecOps, we forget that. Right? I don't want to put this process in place that increases lead time. How many people have read the DevOps handbook and the Phoenix project and all that good stuff, right? Everything that we do on the security side has to contribute to revenue for the company, has to contribute to decreasing lead time. So a lot of what I focus on during my talks and with my customers is what we're doing actually supporting the business in the end. Because as much fun as it is to develop cool things on the business side, if it costs the company money, it doesn't really benefit them, right? So how are we going to do that? Well, digital transformation has been trying to do that for a while. Called digital transformation, agile, DevOps, DevSecOps, whatever your flavor is, value stream management. It's all about, right, speed through automation and reducing lead time. So my view, again, from the security standpoint is, how am I providing security, but still improving quality, improving performance, reducing risk, right, and increasing revenue? Because in the end, that's what the company needs to do. But it all has to come down to this reducing lead time. So developers are developing faster. The front part of this is not going to be news to folks, although sometimes it really is. And I have to remember that not everybody has spent their life in this space. But how do developers get faster? Well, you're using open source components or using open source software. And when I started at Sonatype, I had sales reps and developers and asking questions like, hey, do you have open source software? They didn't even know how to ask the question right. And I'd have CIOs and CTOs say, no, we barely use any open source components. And back then it was 80%, right? 80% of the modern application. Now it's 90% of the modern application. We're not rebuilding loggers, right? So the complexity around security comes from the fact that it's not just that we're using 90% of an application that's not mine. Right? When I start to include all of the different package formats, how many people program in Java? Python, C, JavaScript, all of the above, right? More and more, it's like all of the above, right? So when you start to think about a project that is Java-based, Python-based, and JavaScript-based, now the number of downloads and the number of open source components is just growing exponentially. I don't talk too much about the company, but the company's named Sonatype. Don't get it confused with SonarQube, Sonatype. Most people know us as the Nexus Repository Manager, over 350,000 deployments of the open source version of that. We're the creators and the stewards of Maven Central. So if you raised your hand under Java development, I served up a Java component to you at some point in your lifetime. Right? We serve up all of the Java components in the Maven ecosystem. So we have some unique visibility into this, and then just in the partnerships that we have with the community around NPM and PyPy. So the complexity of it just continues to grow, where the average enterprise is now downloading over 373,000 open source components. And how are they managing that risk? The answer is they're not managing the risk very well at all, right? They don't have a policy in place, or they're starting to have a policy. I've had a handful of conversations today about, well, do you know what your open source policy is? How do you get components approved, right? Most of my large companies still go through a manual approval process for adding a new component. So developer wants a new version of a logging framework. Actually, a developer wants a new component for modeling in AI and ML. Right? In insurance companies and financial institutions, there's a manual process that says, I want this component in this version. And then a security team goes out and tries to do all the research on that component. And 6 to 8 weeks, I don't know why it's 6 to 8 weeks, it's always 6 to 8 weeks later, that component will get approved or denied. Do you think the component's been used at all during that 6 to 8 weeks? We're pretty good at being able to get the thing we need to get our job done and move fast, because in the end, we know we need to reduce lead time. So most enterprises don't know which open source components they are. They don't have a policy in place. You have cyber attacks increasing at over 650%. There's a ton of savings there in reducing the automation. Our insurance company here locally had 3 full-time people called librarians that managed the open source process. Right? They were able to reassign those. And you have to be careful. They didn't eliminate the jobs. They just reassigned them to more high-value items because they could automate the process. And we'll look at how we can automate that later on, why it's so important to automate it. It wouldn't be a tech presentation without a fun diagram. But what that leads to is open source components are the foundation of our applications, right? We need them to deliver faster to our customers. How many of you know if you have an open source usage policy in place? at your company? How many of you follow it? There's a video camera right there. I don't think it's aimed at. So for those on the video, this side is very active, I think, because there's light. Right, so they're very active. This side is very not active because it's, yeah, he's pretty good. So again, interrupt me with questions as you go through. A little bit of history. So again, why is it so important? We know the history. We know kind of where we stand now. We'll go into what's happening over the past couple of years. But typically, an attacker looks at publicly disclosed vulnerability and POC exploits. If you were in the session before this, somebody asked a question about software bill of materials, right? If I've got these publicly disclosed vulnerabilities, why on earth would I want to generate a software bill of materials that I could then publish as part of a public site, because maybe I give or I sell to the US government. So now not only is all my vulnerabilities public, but now every component that I'm using and version that I'm using is now public, right? So, but this has worked well, right? We've sat there, we've waited for public disclosures of vulnerabilities. The second that vulnerability came out, we started attacking it, right? The bad guys, not us. So there are tools out there that allow us to find the unpatched versions of components. And then again, every security presentation would be incomplete without a reference to Equifax. And it's not just that Equifax was a horrible breach. Yes, the open source component of it is the thing that let the bad guys get in the door. It's not the entire attack. It's the cluster thing that happened back behind that entry point, right? Now, they're my customer, a very good customer, post-breach. But what's so important about Equifax is it's everybody, right? It's not just one subset of people's data, it's everybody's data. Your grandma understands who Equifax is, right, at some level. And as we start to look into 2017 and into 2021, if you're familiar with OWASP and their OWASP top 10, for a long time, my company rode the coattails of OWASP number 9, right? Using components with known vulnerabilities. Well, that's a good thing that you probably shouldn't do, but every single one of my customers does. And they continue to do it, so much so that in 2021, it's moved up to 6 in the list of things not to do. We've named it a little bit differently, right? Vulnerable and outdated components. So it's not just about vulnerabilities now, right? It's about, do I have the latest version of something? Or do I have the second to last latest version? Because the latest version actually might be vulnerable, right? We can get into that later. But you can see this part of the problem hasn't gone away, nor will it ever go away. If I have security people that are finding vulnerabilities in software and I'm publishing those, I'm going to have people that are attacking those published components. Questions? It should all be kind of review. Okay. Now, miscofigured, just like I meant to do this, right? This is how mistakes happen, right? Because they just happen. I used to give lunch and learns or the meetups at the bar where I would talk about misconfiguration of files and how easy and how complicated it can be to pay attention to the fact that maybe somebody in this room, checked in their AWS credentials for less than 30 seconds as you're trying to troubleshoot something, and you get it out, you realize you did that, that was wrong. And then you get an email from AWS and saying, hey, did you mean to fire up EC2 instances in every region you have access to? And I said, no, I did not mean to do that. But that's how fast mistakes start to cause these security breach. They're misconfigured tools, they're buckets, they're file shares. It happens to the best of it. It's too complicated. And you layer on that, it's just becoming too complicated to see if I have a phishing attack. Right? How many of you get texts around the time that you pay your AT&T bill or your Verizon bill with your name in it saying, hey, thanks for paying your bill, click here to get your prize? Right? We're in this business, and I have to think about it. Was that actually me? It's just constant. I do not answer my phone anymore, right? So it's constant, and it leads to mistakes like this, where personal data is exposed. So again, the complexity around using open source components, it's not just open source components, right? It's open source frameworks. It's the ecosystems that were in place. It is really, really hard to understand. Do I have all the security mechanisms on my blob stores? Do I have any misconfiguration in my pipelines, right? Am I letting vulnerabilities into my pipeline process that are then feeding into my customers' pipeline processes? And what that's led to is another type of attack, which, again, in 2021, no presentation is complete without the SolarWinds. I'm going to skip by it really fast. But this got the software supply chain in the news and into the enterprise. Nobody really thought about the software supply chain as a supply chain. If you read the DevOps Handbook and Value Stream Management and the Phoenix Project, absolutely you think of it as a supply chain because you're standing over the top of the floor and seeing where the bottlenecks are. I forget all the characters' name. I try not to forget the security guy with the three-wing binder. I think we all relate a little bit to that. But SolarWinds got their name on that phrase into our consciousness. But it's not just them. Right? And now we're confusing, was this a software supply chain attack or was this a zero-day vulnerability? The book I'm reading, and I'm blanking on the title, This Is How They Tell Me the World's Gonna End, New York Times reporter, wow. This is how they tell me the world ends. Pick it up or don't and live happily ever after. It's kind of scary, the whole market out there for zero-day vulnerabilities. So I don't really care at the end, was this a zero-day vulnerability in something or was it a software supply chain attack? But at least it's getting the enterprise and software companies looking at the fact that now the bad guys are trying to be smarter about where they inject vulnerabilities, right? And how can we as a security teams catch that? So a little bit of terminology. I always get upstream and downstream, right? If this is your typical software supply chain, the upstream is, hey, we're going to manufacture the issues into dependencies that have wide adoption and then get further distributed to mirrors. We'll see that distribution here in a second. So if I can fit the vulnerability upstream and then everybody that downstream then uses it, I don't have to sit there and find and wait for a known vulnerability and fit into that world. Midstream, we're using and finding vulnerabilities in the applications. The problems with the applications that we're using today is that for a lot of, I won't say a lot, for a number of the exploits that happen, all it really takes is to do the install, right? Your PyPy install, your NPM install is going to trigger the install, right? It's not just, hey, an NPM install is I download a jar file like I do in Java, and then I attach that to my library. An NPM install is I install it and I kick off a startup script, and whatever's in that package.json is going to fire, right? That's how that whole piece happens. We've used automation and speed to get us into trouble. So we try to influence the tools that people are using. The applications in this midstream are getting used more and more. They're getting put into applications. And then you have your typical downstream, right? I want to exploit my known issues. I want to introduce malicious behavior, right, to affect the clients, the things that can only happen, right? When you look at the Equifax hack, let's call it the Struts 2 RCE, it really only happens if you force an exception on an upload, right? How many of you are testing for that, right? For every exception on an upload. So you actually have to have it deployed, right, for that problem to occur. So in our terminology now, we hear these upstream attacks, midstream, downstream. This is the software development lifecycle. You've probably heard it 12 times today. The upstream is the piece that we're going to focus on a little bit this afternoon. It's one component distributed across different repos can wreak havoc. It's the easiest place. Let me move upstream and I get my exploit in place and all the other components that use it. I don't know if you know this, like this is not just us saying, oh, hey, the thing's in GitHub and then it's going to go into NuGet and PyPy. each one of these package management systems, and again, remember, I'm one of them. Yeah, Maven Central. Each one of these package management systems has packages from the other package management systems, right? So me as an SCA provider, as I'm looking at an application and I see a JavaScript file, and I can index and hash every JavaScript file. I have done that, and I've done it for NPM because that's where all the JavaScript files are, right? Well, unless you install jQuery from the NuGet package library, right? So it gets even more complex, and the spread happens even wider. I'm going to speed through this. How many of you heard about the Code Cove? Okay, maybe I won't skip over this. So on April 15th, they disclosed that a security incident, it's a supply chain attack, right? This is in a testing tools that developers use. It's embedded in the tools that the developers are using, right? And they breached the auditing portion of Code Cove with credentials that were exposed from a Docker image creation process. So again, like a lot of the vulnerabilities and the exploits that are out in the wild, it's a combination of things that are happening here. The complexity is what's leading to the breach. So what they were able to do is modify the bash uploader script that's used by thousands of projects. Right? So now it's embedded in everything that gets distributed downstream. So you start to look at this and you look at the breaches that occur, and nobody knows it's sitting there, right? Octopus is another one of those that luckily was, if you're my age, remember NetBeans? I should probably shouldn't. They still have an IDE. So what amounted to a test run in an older IDE, right, embedding these vulnerabilities and these exploits into where the developers are working, becomes harder and harder. iChart. I'm not going to zoom in. I'm not going to cover every one of these. If you look at our 2021 State of the Software Supply Chain report, you'll see this and give you a history of it. But this is one of those that, again, keeps you up at night as you start to look at the types of attacks that are occurring. We'll cover a couple of key ones that are the simplest almost and the latest, but also can be the most damaging but easier to fix. But the idea is that it's not stopping, right? The evil hackers are getting smarter and faster. If I say I have to automate and I've got DevSecOps and I'm doing automation to reduce lead time, what are they doing? Well, they're automating to improve their chances of getting a payday. Right? They're trying to increase revenue on their side through automation. And typically, Typosquatting and Brandjacking have been probably the last 24 months what I've had to deal with the most. Super simple attacks that go beyond novel, right? I mean, a couple of them are so simple that you're like, of course that's a problem. But the most simple here is kind of this Typosquatting and you guys know what Typosquatting is? I don't know about you either. I can't spell receipt, which means I can't spell receiver, which means I'm, requests, right? There are a bunch of packages that you can mistype, or you can just add a new package called Twilio-npm, right? And have it launch a reverse shell. Well, we discovered this, reported it to NPM, who took it down. But again, your developers don't know, oh, I'm using Twilio and I'm using NPM. So which package should I install? Twilio-npm. So we're seeing more and more and more of these. And as these came out, the issue was all of a sudden the copycats that occurred with them, right? Discord, if you have teenagers, kids, discord.app, right? The whole chat thing for video games. But the same thing, you have a set of packages that are named inappropriately or appropriately, depending on what side you're on, and those get downloaded. So those are kind of easy. Let's be smarter about what we're downloading and what we're controlling. Remember, we're hoping that our enterprise actually has some sort of open source governance process that's not manual, because we do want our developers to have the best, the most up-to-date packages. Right? How many developers in the room? How many people love working on legacy apps? Right? They're mission critical, right? Back in the day, I sold APM software for the companies that were going from mainframe to distributed, right? Remember, we were taking WebSphere off the mainframe, putting WebSphere on a whole bunch of servers. You know, it's the same kind of thing. People don't want to move and work on the old stuff. They want to work on the new stuff. So your developers want to use the latest packages. They want to work on the ML and the AI projects, right? So we have to give them access to that. As we start to give them better access to it, the evil hackers are getting more smarter. I know that's not correct English. More smarter and faster, is it? Yeah. So now we have a thing called dependency confusion and namespace confusion. It's a little bit more sophisticated form of brandjacking, but not so much. The last speaker started to touch on this, but we as a company, and I'll cover it here in a second, we as a company have a automated malware detection system where we start to look at packages, and we flagged a handful of quote unquote security packages that a developer, Alex, was doing a research paper on. So essentially what he did was he said, if I'm Amazon or if I'm Amazon or I'm Zillow or I'm Lyft or I'm Slack, I probably build components that I then use internally, right? So I have open source components that we then publish out to everybody, right? Like Twilio or Twilio-npm. But I also have this inner source is the phrase that more and more people are using. It's the open source software, the software that I build internally that I then host internally. So the idea is maybe I have a repository manager that hosts NPM packages. And my developers are creating their own NPM packages, then post them here. Well, what Alex found out is if Amazon and Lyft and any other company, if I can figure out what they post their internal component name as, well, maybe I can post an external one with a higher version number. And in order to, increase revenue and increase speed and develop faster, I let my developers get latest. Which one do they get? Right? So what you saw on NPM.js, on NPM was components that had a really high version number. And you're like, well, why does this thing only have one version number and it's really high? Well, maybe there's 100 different versions of it in my internally hosted repository, but my clients aren't smart enough to know that. And when I mean clients, I mean like the npm command, when I say npm search or npm install, right? So what you end up with is too many screens and you go back and forth. You end up with this problem where the latest thing that gets downloaded is the vulnerable component, right? If I come back to npm, my last name's Cupitt, C-U-P-I-T-T. And I was like, this is too easy. It can't be this easy. Well, it was this easy. So I mentioned that we're the stewards of Maven Central. We have a process where you have to prove that you own the reverse domain name of a URL or a component before you can publish it. Developers thought that was really slow. They didn't want to do that. They wanted the speed to publish whatever you want. So pretty much in PyPy and NPM, you can publish anything. How many people have published to NPM.js? Anybody? That's your homework tonight. Build a package, publish it to NPM, or build a package and then claim a namespace, right? Make sure you claim a namespace. So here's what happens. If I, as a company, don't claim that namespace, and in NPM world, that ampersand, Cupitt aviation, remember I like pilots and then I did mobile and, right? If I don't, by putting that ampersand there, that claims that namespace as mine, right? So when I build things, I use that namespace and only I can publish into that namespace. Right? But before I claim that, I actually publish as Cupitt Aviation Weather here. Right? So what that allows me to do was, I don't even know if I'm, never demo something you're not ready to demo, but you guys seem really interesting. There we go. Right. So I also have a hosted repository where I have Cupitt Aviation Weather, but I haven't pushed it to npm.js, right? I haven't pushed it to npm.js because it's internal. It's my internal code. So the way the systems work is I do an npm install for Cupitt Aviation Weather latest. And what version do you think I get? 1.1.0. I could have like done a version 100. So the npm client comes in, searches for Cupitt Aviation Weather, goes to npm.js first. It sees it. Oh, there's a latest version. Now I download the malicious version. Kind of pretty ingenious. Right? You just have to guess at the company's package name. So that's exactly what happened. I did an install with this here. I then moved it in the namespace, changed my package.json so the install used my namespace component, totally bypassed that version there, right? So as a company, I mentioned we have a repository manager. So what we did to help customers with this simple attack was say, okay, if I'm going to have an npm hosted repository, can I just tell you that everything that's in this hosted repository is proprietary, right? And oh, by the way, if you know everything that's at npm.js, can you tell me if there is a conflict? Right? So that way I can at least know, right? So as I start to look at a repository and I've got this namespace conflict, now what I'm doing here is, this is a report from our firewall, but what it's done is it said, hey, I see in this hosted repository all these components with this name. Does that exist in the public repository that I have access to? If so, go ahead and alert me so that I can, I can deal with that and make sure I have the namespace covered. Right. So again, the bad folks automating in a way that really, we know it happened before Alex's published paper, but when you start to look at the flood of copycats that happened on NPM and PyPy after that was announced, right? So you announce it here, February 9th, February 12th, we have 300 plus copycats merging into the repos, 575, then 5,000, then 8,000, then 10,000. It's really easy to publish into PyPy and NPM. This is that balance between speed and security. We wanted to go fast. We asked NPM and PyPy to go faster. And what did they do? They let us go faster. And this is the risk that you have. Right? It's inadvertent. Did anybody really think that would happen? I doubt it. Right? Who owns NPM right now? You guys know? Microsoft. Right? So these aren't small companies that own these package management systems. Microsoft has NPM. We have Maven. You don't really own it. You maintain it and spend a buttload of money to maintain it without any gratitude. It's a horrible life. All right, so PyPy and NPM flooded. Okay, if I'm using a repository manager, I can solve that. If you don't have your own namespace, go get your own namespace, right? All right, so our goal now is to automate faster than evil. So in a perfect world, every component that my developer would download would be automatically evaluated. And if anything looks like it might be suspicious, don't give it to my developers, right? Exchange developers with my CI/CD system, my build system, my release system, anything that's pulling open source components to run. If you have a Spring Boot app and none of the components are on that Spring installed, and let's say you put that Spring Boot app into a container and you fire up that container, what's Spring Boot going to do? It's going to go out to Maven, download all the jar files that it needs to start to run. So it's not just the developer downloading, it's all the systems that are automated. If, again, in this perfect world, if after open source security experts, us, determine that the version's safe, let's automatically allow that component to be used. Right? And then if it contains malicious code, go ahead and create a vulnerability and protect it from the supply chain going forward. That's a perfect world. Right? I'm on Halloween kick. Got to think Halloween candy. I love this screenshot, right? Keef cat, Butterfinger. Right? This is the namespace stuff. We don't allow our kids to eat candy until we inspect it. And we certainly don't let them eat anything that's not properly wrapped. Right? It looks like in this room, all of us lived in a different time where we did do that. But you know, if the candy looks wonky, it's suspicious. You know, if you find something bad, it's malicious. Again, we're trying to keep the company alive. Right? So how do you automate this? Well, I can't ask the developers to learn everything about every component. So what we've done is, you know, for every NPM and PyPy package that's released, we analyze these signals in file version, publish. There's over 24 of them. And you know, examples in the file, the number of files updated in the package, the semantic version major gap, the hours between the last commit and the pub date, and the package name, Levenstein distance. There's a lot of machine learning going on, a lot of advanced if-else statements going on here, right? But we do this for every single version because your security teams can't do that. You have to automate this process. Word of the day, Levenstein distance, the distance between two words, right? Am I seeing changes in the name, changes in the version name? I didn't know what that meant. I thought it was a great word to know. It is the distance between two words. It's the minimum number of single character edits, blah, blah, blah. This will be available online, but just look it up. It's kind of cool. This is our pipeline to automate that process. So I can't just stand up here and say, hey, you need to automate security, or you need to shift security left, or you need to educate the developer to secure your application to build better code. No, this is the pipeline to do that previous slide where I have to extract information from the manifest. I have to clone the repo, right? I have to do my Levenstein distance calculations. I don't know how long they take. We have to get the signal calculations, and then we need to predict whether that's suspicious or malicious. Again, I can't ask everybody to do this. Last time I did this slide was, I don't know, July maybe. So these numbers are old, but we, at that point, processed over 7.5 million releases, which is an average of 27,000 releases a day. Right? And on June 13th, that was 138,000 release versions. Right? We automate it because we have to. We can't rely on our security teams to do this work themselves. Right? So what you do after you run all that, you get an integrity rating, normal, suspicious, malicious. And for us, you start to use that to define policy. Right? The part that I can automate on my side is, well, what do I do if something's suspicious? Right? Maybe I quarantine it. We're starting to get smarter. We recognize that, hey, I just can't not give it to the developer, which is what a quarantine does. I can quarantine that component. If we looked at my report over here and I scrolled, yep, what that quarantine means is the repository manager knows not to deliver this to anybody that asks for it. But that's kind of tough, right? I've got a lot more going on there. Now, what we've started to do is say, hey, if the latest version is if the latest version's actually suspicious, or I haven't done the process of evaluating the latest version, should I quarantine it? What I'll do is I'll automatically give the developer or the essentially the NPM client the latest good version. Right, so now we can start to automate the delivery of those components, having the security done, but not just blocking it and say, hey, you can't have this. We're going to say, hey, you can't have this. Now, once that automation happens and we determine that process, that version's good, we can release that, and then you can have that latest version. Right. We're at that point, by the way, now that you probably shouldn't get the latest version, except for your iPhone and your laptop. Just be careful when your teams are just putting latest in there. Right. We're trying to help by serving up not the latest, but the next latest. But it's tough to keep up with that. Right. So putting that firewall in place, and part of it is, hey, if I don't want to give it to, if it's suspicious, don't give it to my developers. Right. So part of that process is for every new download that's requested by a developer or an automation system, I do this process of evaluating against policy, and then I either give it to folks or not. I also have an auto release version of that. So we used to quarantine it and quarantine it hard. You had to go in and waive it. Now we're automating that waiver process. Hey, so if something changes where it was suspicious, but now it's not, every night, go ahead and reevaluate everything I've done. I'm trying to get the developers as much of the good stuff in open source as I possibly can, right? And not just blindly say, oh, hey, you can't have it, right? So this is an example of an NPM install where I've quarantined a component, right? Give them the information that they need to go get that data, right? So part of the information that I provide is I've done this research on every version of every component, and I can tell the developer, hey, based on your policy, this is the version that you can use. So again, as security people, we're trying to empower, well, we're really trying to be the superheroes, right? We're trying to be the superhero to the developer, giving them the thing that they need, or at least as much information as they can to pick the right components, right? And then again, if we determine it's good, have a process that automatically releases that from quarantine. I really want everybody to have an open source governance policy that's really just, it's not based on vulnerabilities, right? It's based on security threat, legal, quality, right? Quality's age. And then, you know, if a component contains malicious code, do the obvious thing, create a vulnerability, protect it from my supply chain. What happens when I create it as a vulnerability? It becomes public and starts to be attacked, right? So there's that piece of it. And I know I'm coming up on time. I would love to say this is all me. I just try to sell it. But you know, we have a team that focuses on this automated detection that, again, these numbers are a little older, right? Over 12,000 packages identified. They're really, Axe, who leads this group, there's a number of blogs. It feels like every day. It is every day because my Google filters are all like that. So if you're in security, try not to set those because otherwise it feels like the sky's falling every day. And but you know, it is, right? It's bigger than cybercrime is bigger than the drug trade by far, by far.